Hey, welcome to another video, and as you can tell, I'm still fighting a cold, so this could get interesting vocally. But anyway, wanted to show you the difference between scaling up and down in unit analysis when we're converting units of measure. So first, we're going to take a look at this sample problem, example 1. It says a person is 7 feet tall. How tall is a person in inches? All right. Now, as you can see here in our steps, the first thing it says is to make your, that should say 4 lines. So 4 lines just basically means we're going to have 2 ratio bars or fraction bars with the equal sign. So you get it? 4 lines. And then you're going to start putting information in here. Now, the first thing we want to find the right equation. Alright, and if you think about it, we need to go from feet to inches. So, well, you know that 1 foot is 12 inches. So that's the right equation that we're looking for. Then we need to write that as a ratio. Okay, so what would the ratio be? Well, it doesn't really matter which one we put on top. We're going to put one of the numbers up here and one of the numbers on the bottom. Okay, so I'm choosing to put 1 foot on top and 12 inches on the bottom. But you could do the other way, 12 inches over 1 foot. And then write the given and line it up. So our given was up here. Alright, so it might be a good idea to circle the given when you read these problems. So it is 7 feet tall. So we want to put it across so it's lined up with the units. So inches are on the bottom, feet are on the top. So we're going to put the 7 up here so it lines up with the feet. See that? So we have feet and feet on top. Then we're going to scale up or down depending on the situation. But in this case, we know we're going to go up because it's 1 to 7. So we need to ask ourselves, what times 1 gives me 7? And it is 7. So I'm going to multiply 12 by 7 essentially. Alright, so if you want to go to the side or use a calculator, 12 times 7 I believe is 84. So our answer then would be 84 inches. We could box it there, or we could write it down here. Okay. We want to make sure we box or circle it so that whoever's grading knows exactly what our answer was supposed to be. Alright, now let's take a look at unit analysis. Alright, same problem. A person 7 foot tall. How tall is a person in inches? Okay, the first thing we do though in unit analysis is we write the given. So it's the first thing we do. Please excuse my handwriting. I'm kind of writing around my tripod, so it's a little messy. I promise I write better than this. So we're going to write the given. Okay, what is the given? The given is 7 feet. Okay, so we're going to write that at the top here. And then we're going to find the right equation. Well, assuming we didn't already have it over here, we're going to write it here or find it in a table somewhere. Now, why is that equation important in unit analysis? Well, let me write that out here so we have that. Find the right equation. Okay? And then write it as a ratio multiplied by the given. Okay, so be sure to put the given unit on the bottom. Alright, so here is our given. We got 7 feet. I want to multiply this times this ratio. Okay, so I want feet to be on the bottom so that it cancels out. So I'm going to put 12 inches on top, feet on the bottom. And then, just to double check, those cross out. So basically what I've got is a 7 over a 1 times a 12 over a 1, or 7 times 12, because these ones really won't matter. Okay, and then again, like I know over here, it's going to be 84. So my answer is 84 inches. Okay, so finish up our steps. We're going to multiply the given by the top number, then divide by the bottom number. Okay? Now let's look at another example here. A tree is 12 feet tall. How tall is the tree in yards? So again, if we're doing unit analysis, if we're using scaling up and down, we want our 4 lines, and then we want the right equation. Well, in this case, we want feet and yards. Okay, there are 3 feet in 1 yard, so we want to write that as our ratio. So 3 feet over 1 yard. Alright, and then we write the given. The given was 12 feet, so we want to put it on top. Okay, and then to get from 3 to 12, I'm scaling up by a factor of 4. So multiply that by 4, and I get 4. And for what? Well, it's on down here with the yards, so we're going to say it's 4 yards. So how tall is the tree in yards? It is 4 yards. Okay, now unit analysis takes this problem on a little different. We're going to start with our given. So we start with 12 feet, and then I want the equation. 3 feet, it's 1 yard, and then I want to turn that into a ratio with the given units, feet, on the bottom. So I'm going to put my 3 down here, and that means my 1 yard is on top. Now, look how this is a little different than our problem before. Before we just multiplied across the top. We didn't really have to divide. Here, if I multiply across the top, 12 times 1 is going to give me 12. And then the bottom number, 3, means I need to divide the 12 by 3. And no surprise, since these are the same exact problems, I get the same answer. Again, this is just a different strategy. Okay, finally, our last problem. A box weighs 5 pounds. How many kilograms is the box? Now, here's some vulnerability. I didn't choose the best conversion equation. Okay? So as I was practicing this, I decided this one would work better. And you can check in the book. This is legit. Okay, it is 1 pound equals 0.45 kilograms. Okay? Not going to explain necessarily why I did that, but you might figure it out as we go through the problem. So we want our 4 lines. Okay? Start with this as an equation. Again, it does not matter which goes where. I'm going to put pounds on top. Be careful, that 1 kind of looks like an L. So I'm going to separate them enough. And then 0.45 kilograms. Here's my given, 5 pounds. Where do I want to put it? Well, I don't want to put it down here next to kilograms. I want to put it up here, because it's 5 pounds. Pounds goes with pounds up here. Okay, and then I want to scale up by a factor of 5. You could figure that out. Let's do that. Just a model here. You could do it on a calculator, which is probably what I would go with, but just a model. Multiplying decimals, 5 times 5 is 25. 5 times 4 is 20, plus the 2 would be 22. And move it over 2 places. And so my final answer would be 2.25, and it's kilograms. Okay, so 2.25 kilograms is how much this box would weigh. It's approximately half, okay, which makes sense because 0.45 kilograms is about half of a pound. Okay, last but not least, over here with our unit analysis, we start with the given. We got 5 pounds, and I'm going to multiply that by my equation again. You know what? Let's do something fun. Let's use that equation. I crossed it out, but let's use it. Alright, so I've got 1 kilogram. Let me rewrite it. Okay, and I'm going to put that right here. Actually, let's try that again. This is really professional. Yes. This video is going to make me famous. I just got a feeling. Alright, and then we're going to put the pounds on the bottom. Okay, because we want the pounds to cross out. Okay, and that means when I multiply this, I'm going to have 5 over 2.2, and that's going to give me my kilograms. Okay, what is 5 divided by 2.2? Let's go to the calculator here. Always a good thing. 5 divided by 2.2. And look at that. Now wait a second. Those numbers line up. So this is just a great example to show you, depending on the conversion equation, you might end up with a slightly different answer. Now before you get all excited saying, well, if I get my answer wrong, it's because I used a different equation. Look, they're very, very similar. That's only 2/100ths off of this. So whoever wrote these equations rounded differently. This one rounded to 100ths place, this one rounded to the 10ths place. See that? So that's why our answers are slightly different. Alright? They're still but pretty close to each other. Alright, so I would feel confident in boxing that answer. So you might get a slightly different answer than your classmate or your neighbor, depending on which equation you use, but they're still very, very close. Alright, so hopefully you could see through my chicken scratchings and you could hear through my cracking voice. But again, this will keep me from having to repeat this 3 times for my classes. So hopefully this is helpful, and it also gives you something to look at later when you're at home trying to work on the homework. Well, until next time, this is Mr. Stirtz. We'll see you later.